Aye, Captain. 5.6, rational root theorem. All right, let's see what the rational root theorem says. Let p of x equal ax to the n power plus ... That's just a generic way of writing any polynomial. Then the roots of p of x must be a factor of the constant or a factor of the constant over the factor of the leading coefficient. All right, so that's a little bit confusing, so I'll show you what that means in an example. Okay, so if I gave you a polynomial, x to the third plus 3x squared plus 6x plus 4 is equal to 0, and I ask you to solve for x. So I asked you to find the x's or find the roots or the zeros. So all of those mean the same thing. What the theorem said is that if we look at the constant back here, the 4, the answer to this equation has to come from this 4 or factors of the 4. All right, so the first part of the homework is going to ask you to list what are the possible answers to this equation. And here are the possible zeros, the possible answers. It's all the numbers that go into 4. Okay, so it's positive 1 goes into 4, negative 1, positive 2, negative 2, positive 4, and negative 4. Those are the numbers that are factors of 4, positive and negative. All right, so what they want you to do is check to see which of those 6 numbers actually is the answer. All right, and the way we do that is you can either plug it into the equation to see if it's equal to 0, but we did learn a faster way called synthetic division. And so the more you do synthetic division, the faster it's going to go. So let's go ahead and do synthetic division. And what you do is you just take one possible answer at a time. So I took 1 and I plugged it in to those numbers, 1, 3, 6, and 4. Those are the coefficients. And again, if you remember from synthetic division, you bring the first number down, multiply the 1 with that 1, put it there, add those 2 to get the 4, then multiply, put it there, then add, then multiply, then add. All right, what that means is if we have a remainder, then 1 was not an answer. So we cross that out. And then we do it all over again for the next one. Let's try it for negative 1. Plug it in, bring the first one down, multiply, add, multiply, add, multiply, add. If you notice, we have remainder 0. What that means is negative 1 is a solution to that equation. So we found one solution. But the problem says there are going to be 3 solutions, so we have to find the other 2. All right, so to find the other 2, you take these numbers right here, the 1, the 2, and the 4, and you make another polynomial. I know you can't see it, but there's a 1 here, there's the 2, and there's the 4. And remember, we always use the exponent that's 1 less than the highest degree in the original problem. Okay, doing that, we now just have a quadratic equation, which you know 4 different ways to solve the quadratic equation. For this problem, I'm just going to go straight into using the quadratic formula. And plug all those numbers in, the a, the b, and the c, simplify. Notice that there is a negative in this square root, which means you're going to have an imaginary answer. There it is. I simplified that negative 12 to 2i radical 3. And then again, if all 3 numbers reduce, go ahead and reduce all 3 numbers. Our final answer is negative 1 plus or minus I radical 3 and negative 1. People always forget about that negative 1, but that was the first answer. What we got were the second two answers from the quadratic equation, totaling 3 answers altogether. All right, let's do another one. There it is, 15x to the third minus 32x squared plus 3x plus 2. The first part of the homework is going to ask you to list out all the possible answers. Now this one's going to be a little bit different because I told you in the last example to look at the 2. But all of a sudden, what are all of these things? All right, so I'll explain right now. So there were the original possible answers, plus or minus 1 and plus or minus 2. They are factors of 2. But if we go back and look at the theorem more closely, it did say the factors of the constant divided by the factors of the leading coefficient. So you have to divide it by the factors of 15. So I had to do 1 divided by 15 and 2 divided by 15. But then we had to also do the factors of 15. So the factors of 15 were 3. So we had to do 1 over 3 and 2 over 3. And then 5. That's also a factor of 15. And then we had to do 1 over 5 and 1 over 2 over 5. All right. So it turns out that the theorem wasn't as easy as we thought, because now we have a whole bunch of different possible answers to figure out for this equation. So let's go ahead and check one at a time. Let's plug in a 1 to the 15, the negative 32, the 3, and the 2. Synthetic division goes by pretty quickly. We have a remainder of negative 12, so 1 is not an answer. And then I think I tried negative 1 as well. Negative 1 was not an answer either. All right, so let's try 2. Do a little bit of synthetic division in there. We have remainder 0. So it turns out that 2 is an answer. We'll box that. And then from there, we're going to go ahead and write a new polynomial with these coefficients. 15x squared minus 2x minus 1. And then use the quadratic formula to get the other two answers. Notice when you square rooted this one, there is no negative, so we don't have imaginary answers. And actually, we have a perfect 8. Square root of 64 is just 8. That will give us 2 answers. The first one is 2 plus 8, which is 10 over 30. Reduces down to 1/3. And then 2 minus 8 gives you negative 6 over 30 and reduces down to 1/5. So there are our 3 answers. 1 here, and the 2 that we first got. All right, let's go ahead and do one last example. But it is tricky, and it's not that tricky. It's only because we have 5 answers to go through. So that's kind of fun. Let's list all the possible answers. Those are the factors of 4, which is plus or minus 1, plus or minus 2, and plus or minus 4. And then if you notice, the front is just a 1. So if it's a 1, you don't have to do the whole fraction thing. Okay, so let's go ahead and test some points. Let's test 1. I always like to test 1 first. You don't have to do the 1 first. You can do any of those 6. There are the coefficients. Bring down the 1. Do a little bit of synthetic division. And we have remainder 0. So we were lucky to know that the first answer is 1. All right, from there, we're going to write a polynomial. Remember, it's the polynomial that's one less than our original degree problem. And so it's going to be x to the 4th. And then down 1 every time. And then since it doesn't quite work with a quadratic formula yet, because it's not a quadratic, we get to do the problem again. List all the possible answers, all the factors that go into 4, and then test it out again. And it looks like if one already worked, it could possibly work again. And so I'm going to try 1 again, because this list of new possible answers still includes 1. All right, so go ahead and do synthetic division with this new polynomial. Simplify. It turns out that 1 doesn't work on this one. So the answer, the 1 doesn't happen again. I already tried -1. -1 didn't work. And so let's try 2. And it looks like when I try 2, two does work. So we were able to find a second answer. And then from there, we're going to go ahead and write another polynomial. There it is, using the coefficients 1, 2, 1, 2 from here. All right, and guess what? We do the problem again, listing all the possible answers. But now we're just doing factors of 2. There it is. And then just so you know, since back here we found out that the 1 doesn't work anymore, then you don't have to try the 1 because it won't work anymore. Okay? So let's go ahead and try, I actually tried -2. Plugging it into synthetic division. It turns out that -2 works. So tried 1, tried -1, tried 2, none of those work, but -2 did work. And so -2 is our third answer. So we got 3 answers. Go ahead and write another polynomial with these coefficients. And then now we finally got the equation down to a quadratic. You get to use a quadratic formula. If you don't want to use a quadratic formula with this one, you don't have to, because this one actually is the sum of perfect squares. I hope you guys remember the sum of perfect squares formula. If you didn't, then fine, go ahead and use the quadratic formula. But I was able to factor this to get x equals I and -I. And those are the other 2 answers. So totaling 5 answers altogether. Okay, so that is a lot of work. It's a lot of guessing and checking, but synthetic division makes it go pretty quickly. You got to guess and check, guess and check, guess and check. But hopefully you can guess a lot faster and get to the answers a lot faster. Okay, go ahead and try the homework.